All right, so now we have polynomials that look like this. A plus bt squared. Okay, so first off, to find out if it's a subspace, does it have a zero vector? Yes. I can let A and B equal 0, and that will give me P of t equaling the 0 vector. So that I'm allowed to set A and B, but not t, correct? All right, so let's look at the second one. If I take a P and a Q that are already in the subspace, so let's make A1 plus B1 t squared, A2 plus B2 t squared, and if I add these two together, do they stay in the subspace? That's the question. A1 plus B1 t squared, A2 plus B2 t squared. I get A1 plus A2 plus B1 plus B2 times the t squared. Yes, this is the same structure of the polynomials in this subspace, so yes, it stays in the subspace. Oops, number 3. If I multiply a real number times the polynomial that's in the space, so if I take C times A plus B t squared, I get CA plus CB t squared. This is in the same structure of those polynomials, so it is closed under scalar multiplication. So therefore, this is a subspace. All right, let's look at polynomials of this kind. Is there a zero vector? Is there a zero vector? I can let B equal 0, but I'm not allowed to let A equal 0. So no, I cannot get a zero vector. I cannot get to P of t equaling 0. So no. So I could be done, right? Could be done with just that. Or, let's check and see what the other one. If I wanted to check to see if it was closed under addition, I'd have to make up two items that were already in. So let me do a bt squared and at squared. If I add these two things together, 1 plus bt squared plus 1 plus at squared gives me 2, and then an a plus a b there in front of the t squared. So because of this 2, it is not of the correct format. It's not the 1. It is not closed under addition. If I take two things and I add them together, they do not stay in the set. Could be done, right? Could be done and say, no, I just did number 2 and that's it. Or I could look at C times P of t. If I take a number C times a polynomial that I know is in there, I get C plus CB t squared. This is not a 1 here, so it's not in the space. So not a subspace. So for all 3 reasons, this is not a subspace. Okay. Now move to a little bit of a different kind of territory. If I take points x, y in R2, which could be written as, x, y like this, all the x's that are bigger than or equal to 0 and all the y's that are bigger than or equal to 0. So I'm just going to draw a picture. So it's these here and these here. It is including 0, so it includes the origin. So that's kind of good. So is the 0 vector in there? It is, right? So 0, 0 is in the subspace by definition. Okay, done. If I take two things, so if I take an xy point, so I'll call it x1, y1, and I add on an x2, y2, right? And these two things are in here already. Do I stay up there? Do I stay in the first quadrant? Yes, because I'm adding in both cases. All right, if I take a constant, c being a real number, and I multiply it by my x1, y1, I get cx1 and cy1. Is it in the space? Let's think about it. If I take a point here and multiply it by c like 2, it stay here. But what if I multiply it by -1? Take an xy point of 2, 2, multiply it by -1, I'm out here. If c equal -1, this is not in the subspace. So not a subspace. All right, I'm going to stop here.